Hey everyone, welcome back to Biomed Insights. Today we're diving into an interesting topic, the different types of joints in the human body. Let's get started. Our joints are what allow us to move in various ways. They connect our bones and come in different types, each with a unique function. We can classify joints based on their structure and how much movement they allow. Let's first look at the structural classification. First up, we have fibrous joints. These joints are immovable or allow very little movement because the bones are connected by dense connective tissue. An example of this is the membrane between the ulna and radius. Next are cartilaginous joints. These allow more movement than fibrous joints but are still quite limited. The bones in these joints are connected by cartilage. An example of a cartilaginous joint is the pubic symphysis. Lastly, we have synovial joints. These are the most common and most movable type of joints in our body. They have a fluid-filled cavity that allows a wide range of movements. Examples include the shoulder and knee joints. Now, let's talk about how we can classify joints based on their function. Basically, how much they can move. First, we have the ball and socket joints, which consist of a spherical head of one bone fitting into a cup-like depression of another bone. The shoulder joint is a classic example of a ball and socket joint. The head of the humerus forms the ball part of the joint, while the shallow cup-shaped glenoid cavity of the scapula serves as the socket. Then there are hinged joints. They allow movement primarily in one plane, like a door hinge, permitting only flexion and extension. The elbow joint is a hinge joint formed by the articulation of the humerus, upper arm bone, with the ulna and radius, forearm bones. It allows for movements like flexion and extension of the arm. Pivot joints, also known as rotary joints, are a type of synovial joint in the human body that allow rotational movement around a central axis. The atlantoaxial joint between the first and second cervical vertebrae, C1 and C2, is a pivot joint. It allows for rotation of the head from side to side, such as when shaking the head no. Condyloid joints allow movement in two planes, primarily flexion and extension, as well as some abduction and adduction. The radiocarpal joint in the wrist is a condyloid joint formed by the articulation of the radius and a row of carpal bones. This joint allows for flexion, extension, abduction, and adduction movements of the hand. Saddle joints are similar to condyloid joints but have a greater range of motion. They allow for flexion, extension, abduction, adduction, and circumduction. The carpometacarpal joint of the thumb is a saddle joint, where the trapezium bone of the wrist articulates with the first metacarpal bone of the thumb. This joint allows for various movements. And finally, gliding joints. A gliding joint is a type of synovial joint in the human body, characterized by the sliding or gliding movement of the articulating surfaces of bones. Intertarsal joints allow for subtle gliding movements between the tarsal bones. These movements contribute to the flexibility of the foot, facilitating actions such as walking, running, and balancing. To sum it up, our joints are amazing structures that allow us to move in so many ways. From the immovable joints in our skull to the highly flexible ball and socket joints in our shoulders, each type has a specific role. I hope you enjoyed this quick tour of the joints in the human body. Thanks for watching. If you found this video helpful, give it a thumbs up and don't forget to subscribe to our channel for more interesting content. See you next time.